Hello. Today I will be discussing my experimentation and results for Physics 2211 Lab 2 on the motion of a falling object. This experiment aims to track an empty cup's motion after being dropped from rest. The results of the tracker will be compared to two computational models, which one considers the effects of gravity alone on the cup, and the other considers the effects of gravity and drag on the cup combined. The results of this experiment and the two models will be graphed in a plot of time versus position to visualize the differences. This experiment looks at multiple physical principles, including velocity and position updates, net force, gravitation, and drag. Here are some formulas used in this lab. There is the gravitational force, drag force, velocity, and position updates, and expanded velocity update formulas. This picture shows the interaction between drag and gravity. The system for this experiment was the cup, and the surroundings were everything else. The cup was dropped from rest and took about 0.633 seconds to hit the ground. The initial velocity was 0 meters per second as it was dropped from rest, and the initial position was 0, 0, 0, as the axes were centered on the cup and tracker. The cup's initial position and velocity were input into the code. Delta t was set to 1 divided by 30 to match the frame rate of the recording. G was set to 9.81 meters per second squared, and J hat was set to 0.10 as down was the y-axis in this experiment. The B value was found using trial and error. Fg was calculated using the cup's mass, 9.81 meters per second, or G, and the direction vector J hat. The velocity and position were updated with their respective formulas using the FNet calculated. As we can see, the computational model does not match real values very well and predicts the cup to move way further than it really did over the same time interval. This suggests that there may be another force acting on the system. We will adjust the previous code to include drag force. Drag force is in the opposite direction of gravity, and when is added to give F net, it will be a smaller total force. Velocity and position will be updated with this new F net calculated, including drag force. As we can see, this computational model is much more accurate, and now the cup is predicted to travel a nearly identical distance to the real data. Gravity-only model does not match the data very long, and the predicted final position is 2.08 meters compared to the tracker value of 1.311 meters. Computational model with gravity only was 63% accurate to true data. Gravity plus drag model matches the data much better. Predicted final position is 1.313 meters compared to the tracker value of 1.311 meters, and the computational model with gravity and drag was 99.8% accurate to the true data. What if down was considered the negative y-axis instead of the positive y-axis? This would cause all the values in the results to be negative instead of positive. What if drag was not a factor affecting the cup in real life? Then in this case, the computational model using only gravity would be much more accurate to the true data. What if the object was thrown down instead of dropped? In this case, the cup would reach terminal velocity much quicker and there would be less of an exponential increase in position. What if something like a heavy ball was dropped instead of an empty cup? In this case, drag would have been much less of a factor and the ball would have reached terminal velocity quicker. Thank you.